Let's quickly summarize the key points of our discussion. Composite sailing comprises of combination of great circle sailing and parallel sailing. The highest latitude not to be exceeded by vessel during a voyage is called as limiting latitude. Reasons that could necessitate limiting latitude during a voyage could include, amongst others, great circle track passing over non-navigable waters, weather routing advice to avoid high latitudes, or ice conditions in the high latitudes. So if there are reasons to limit the latitude, then to strike a balance between the shortest distance and a safe track, we could use this, what we have called as the composite sailing. Having discussed the concept of composite sailing, now we list down certain steps which shall facilitate in making of the diagram and solving the problems related to composite sailing. We first plot the departure and arrival position in correct relative orientation to each other, and the same care needs to be exercised what we learned when we learned to make the PAB triangle. Here is position A and here is position B. Then we identify the appropriate pole. The pole of the hemisphere in which the limiting latitude lies would be the appropriate pole. Then we draw the meridians of A and B. Now, if it was a GC problem, we would have drawn the GC track from A to B, but in this case, we will mark off the limiting latitude. And the red one in the diagram is now the limiting latitude. Next is we draw a GC track passing through A with its vertex in the limiting latitude, the way the green track has been drawn. And here is the vertex of this track, V1. Likewise, we draw a track between P and limiting latitude with the vertex in the limiting latitude, and P2 is the vertex of that track. Now this entire track from A to B has three stretches. One is A to B1, which is GC track, V2 to B, again a GC track, and V1 to V2, rumb line sailing along the limiting latitude. Now we can draw the meridians of V1 and V2. Angle at V1 would be 90, and likewise angle at V2 would also be 90. Now we get two right angled spherical triangles. One is PV1A, other is PV2B, which we can solve using our Napier's rules.
So beta, is it clear up to here? Any doubts?
No, sir.
Okay, all right.
Now let us first mark the parts which we can figure out from the information that may be contained in the question. Now this is the colat of A. I'm sure all of us can calculate knowing the latitude of A. Likewise, this would be the colat of B. Then this will be the colat of V1. Now, since you know that V1 lies in the limiting latitude, so you know the latitude of V1 and V2, and hence you can calculate PV1 and also PV2. The longitude of A and longitude of B shall give us this angle, which is the D long between A and B. So this angle is also obtainable. Now, having identified the parts which we may know, we can use Napier's rule to calculate which all parts. Let us mark them also. We can calculate this angle. This will be the D long between A and V1. So knowing the longitude of A, we can use this D long and get the longitude of V1, whose latitude is already known to us. Then we can solve for this angle at A, and this angle shall help us in getting the initial course of this GC track AV1. We can also solve it for this side AV1, and this shall be the GC distance between AV1. Likewise, we can solve triangle PV2B. This angle will be the D long between V2 and B. Knowing the longitude of B, we can get the longitude of V2, whose latitude is already known to us. We can solve for angle B, which will help us in figuring out the final course when the vessel reaches B along the GC track V2 to B. We can also calculate side V2B, which will be the GC distance on this last leg of the voyage. Now, having known this full angle, having known these two angles, now this angle can also be obtained. This will be D long between V1 and V2. Now, when we know the D long between V1 and V2, and we also know the latitude, we can calculate by parallel sailing formula the distance along this track. That will be the rhumb line distance. And this way we'll be able to get the total distance, which will be sum total of all the three legs. We shall be able to get the initial course, and we shall be able to get the final course as well.
So this is the complete process summarized, and this is how the diagram is going to look like on our answer sheet beta. So any doubts up to here?
Sir, it is required to calculate always this big angle P, or we can take this V1 longitude and V2 longitude and get the D long.
Beta, you can do it by any of the methods, whichever you feel comfortable and convenient. If you calculate the
Because
longitude of V1 and V2, then straight away you can get the D long between them. That's also perfectly all right.
because anyhow we'll be calculating the longitude for the position. So we have the longitudes.
No, the question will not require calculating the longitude of the vertex unless it is specifically asked in the question. So you will not need to
Okay.
calculate the vertex longitude. Uh, but if it is asked in the question, find out the position of the vertices, then in that case, yes, when you get the longitudes of both the vertices, you can straight away get the D long.
Okay, sir.
Okay. Any more doubt, beta?
Awesome.
Okay. All right. So shall we practice one more question then?
Yes, sir.
Okay, let's see.
Having understood the concept of composite sailing, let us now solve a question. Calculate the
So beta, this is the question which we have.
initial course, final course, and distance along the composite track from 37 degrees 40 minutes north, 141 degrees east to 36 degrees 48 minutes north, 122 degrees 40 minutes west, with a limiting latitude of 42 degrees north. So we mark off departure position A. Now in relation to this, we mark off arrival position B, which shall be to the east of A and slightly to south. It comes on the screen. Now we mark off the appropriate pole, as the limiting latitude is north. So the appropriate pole is north, up on the screen. Now we draw the meridians of A and B. They also show up on the screen. Now, if we had to take a great circle track from A to B, we would have drawn the arc of great circle passing through A and B. But in this case, we have a limiting latitude of 42 degrees north. So we draw the limiting latitude, as you can see in the diagram, 42 degrees north. Now we draw an arc of great circle passing through A with its vertex at the limiting latitude. You can see with vertex at V1, the green part. Likewise, we draw another arc of great circle passing through B with vertex at the limiting latitude, and the vertex being V2. Now the vessel shall be moving along the track A to V1, which shall be a great circle track, V1 to V2 along a rhumb line track, and V2 to B along a great circle track, completing our voyage from A to B. Now we draw the meridian of V1, angle at V1 is 90. We draw the meridian of V2, angle at V2 is 90. Now we mark off parts that we can calculate. Now, PA, we all know, is colat of A, and value is 52 degrees 20 minutes. Then PV1 is the colat of V1. Now, V1 and V2 both lie in the limiting latitude, so their latitude is 42 degrees north. Therefore, PV1 is 48 degrees. Likewise, PV2 is also 48 degrees. Now, PB would be the colat of B, and value is 53 degrees 12 minutes. The longitude of A and B give us this angle at the pole, which is the D long between A and B. And this value is 96 degrees 20 minutes. So now what we have done is we have marked the parts which are available to us. And using the two right angle triangles, now let us also identify what all are we going to calculate. We can calculate this angle. This will be D long between meridian of A and meridian of B1, and that can help us in finding the longitude of B1, whose latitude is already known. We can calculate these angles also, this angle. This angle will help us to calculate the longitude of V2, having known the longitude of B. Now, this full angle is known to us, 96 degrees 20 minutes. So this angle can also be calculated. So all these three angles at P, we will be able to calculate. We can also calculate angle A, and this shall help us in giving the initial force when the vessel sets sailing on this GC track at A. We can also calculate angle B, and this shall help us in getting the final force of the vessel. We can get this distance A to V1, distance V1 to V2, and distance V2 to B. All these added together shall give us the total voyage distance. So now we solve the two right angle triangles to find the missing parts. We first deal with triangle PV1A, and this triangle in the diagram is shaded for easy identification. It is this triangle we are talking about. We make the Napier's cartwheel with V1 being 90. And I'm sure as the cartwheel is being completed, you can also revise with it. So there the cartwheel gets completed. Now in the cartwheel, we identify the parts that are known to us. What we know is PA and PV, so they get identified in the cartwheel. Other three parts we can calculate using Napier's rule, so they come up with question marks. Now we can apply the Napier's rule. We can first apply for AV1. Sine of the middle part is equal to product of the cosines of the opposite. When we put the values, we get AV1 is equal to 24.045 degrees, which multiplied by 60 becomes 1442.7 nautical miles. That is the GC distance from A to V1, and this distance we transfer to the diagram here. Now we write the formula for angle P of the triangle. Sine of the middle part is equal to product of the tangent of the adjacents. We put the values and we get the value of P as 30 degrees, 58.8 minutes. It's transferred here. Now this is the D long between A and V1. So if the question wanted the coordinates of V1, then we could have found the longitude of V1 by applying this D long to the longitude of position A. However, since it's not required, so we are skipping it. And we write the formula again now. And obviously this time we want to calculate angle A. So sine of the middle part is equal to product of the cosines of the opposite. When we put these values, we get angle A as 69 degrees, 51.2 minutes. This value we transfer to the diagram here. Now we can solve the triangle PV2B to find the missing parts therein. The triangle is shaded, so this is the triangle in question. So we first make the cartwheel for right angled triangle, right angled at V2. So So this is the cart wheel with V2 being 90 and other parts being filled in the cart wheel clockwise from V2. Now we identify the known parts. Known parts are PV2 and PB. So PV2 and PB are known to us. Other three can be calculated. So we have question mark out there. Now we apply Napier's rule. First we can calculate BV2. And when we put the values, we get BV2 as 26.462 degrees, which is 1587.7 nautical miles. And this distance we put up on the diagram here. So the distance on the GC track from V2 to B is 1587.7 nautical miles. Now we write down the formula for angle P of the triangle. So here is the formula, product of the tangent of the adjacents. Put the values. Angle P comes to 33 degrees, 58.9 minutes, and the value of the P goes into the diagram. Again, had the longitude of V2 been asked for, we could have applied this D long to the longitude of B to get the longitude of V2. Not required, so not being calculated. Now we write the formula for getting angle B in the triangle, product of the cosines of the opposite. And when we put the values, we get B is equal to 68 degrees, 08.3 minutes. The value comes out here in the diagram.
So beta, up to here, okay. Are the answers matching?
Yes, sir, match.
Okay, beta, great.
So now we have calculated all the three parts of the triangle PV2B. So now, if you see in this diagram, there are only two question marks left. Rest of the unknowns have already been calculated and filled in. One is this angle. Now, since we know this angle, we know these two angles now, so this angle can be easily found. So now angle APB is 96 degrees 20 minutes. The other two angles are known to us, and this way we get angle V1PV2, that is this angle, as 31 degrees 22.3 minutes, and this value goes into the diagram. So now only missing part is this rhumb line distance. Now we know this 31 degrees 22.3 minutes is the D long between V1 and V2. Also, the vessel is doing rhumb line along 42 degrees north. So this distance shall be corresponding departure in this latitude. So by parallel sailing formula, we know this cos V1 V2 will be equal to D long into cos of limiting latitude 42 degrees. When we put the values, we get distance V1 V2 as 23 degrees 18.8 minutes, which is equal to 1398.8 nautical miles. So we get the distance V1 V2 using the formula cos lat is equal to departure upon D long. This distance goes into the diagram. Now everything in the diagram has been calculated, whatever was missing. So whatever was earlier known is shaded with green ticks. Whatever has been calculated is indicated by these yellow highlighted values in the diagram. Now let's come to summarizing of the answer now. Now the composite track distance from A to B shall be sum total of these three distances, and you can see that comes to 4429.2 nautical miles. The second requirement of the question was the initial course. So let's go to the diagram and mark out or place a vessel as she would be heading at A. Now, as explained in the earlier videos, let's mark off the initial course clockwise from true north at A. This arrow represents the true initial course. Now we can see clearly that angle A that we calculated is directly equal to the initial course. So therefore, initial course is equal to angle A expressed in three-figure notation, 069 degrees, 51.2 minutes true. Now to get the final course, let's place the vessel as it would be as it reaches B. The vessel would be as this. Now, clockwise from true north at B up to the ship set, let's mark up the final course. This represents the final course here. Angle B calculated is this one, and we can see final course will be 180 minus angle B, and that's how we can get a final course, that is 180 minus angle B. The final course is 111 degrees, 51.7 minutes true. And this way we get all that was asked from us to be solved in this particular question. I'm sure with these simple steps, the entire process, whatever we had learned, discussed, gets covered through this question.
Sir,
Go ahead, beta. Ask.
सर ये जो P3 की वैल्यू आ रही ना सर, यहाँ सर हमारी मतलब मेरी आ रही सर 33°48 और
किसकी
यहाँ
बेटा? जो ये वाला एंगल है,
हाँ
विक्टर
सर,
टू पापा ब्रेवो।
Yes, sir. 48.9.
48.
यस सर 48 आ रही है।
48.9.
ओके, ऑल राइट। सो 33:48 आ रही है।
यस सर 33°48 मिनट 51.96 सेकंड।
Okay, beta. All right. So there may be mistake in this. Not an issue. It is okay.
यस सर।
Okay. और कोई डाउट बेटा?
बस सर।
Excuse me, sir.
आप बोलो बेटा।
ये V1 V2 का D long we can calculate by getting the longitude.
बेटा ये किसी के माई बैकग्राउंड में ना हैमरिंग की नॉइस आ रही है, सो अदर पीपल कैन म्यूट देयर माइक प्लीज। हाँ, अब बताओ बेटा डाउट।
Yes, sir. मैंने V1 and V2 का longitude calculate किया था.
ठीक है।
The other way to get the D long between V1 and V2.
That's right.
तो सर उसमें V1 का longitude was coming 171.98 degrees east, adding angle A to initial position.
ठीक है बेटा।
एंगल ए नहीं सर, आई मीन वो जो P था, फर्स्ट P था।
That's right. Angle P added to the longitude of A.
Yes sir.
That's
And
right.
same way जो पोजीशन B था,
Right.
उसमें से वेस्टर्ली जो लॉन्गिट्यूड था उस पे मैंने वहां का P ऐड किया, तो
ठीक
मोर
है बेटा।
वेस्टर्ली एक लॉन्गिट्यूड आएगा।
Correct. That's right.
So it was coming 169 degrees 14 minutes west.
169 आ रहा है बेटा या
सर
159?
156 आ रहा है सर शायद।
हाँ 156 आएगा बेटा। See this
156 28.8 वेस्ट।
Yeah, that's right. 156 आएगा बेटा।
हाँ, फिर कैलकुलेशन, मेरा कैलकुलेशन गलत है सर।
ओके
ढंग से करा करो ना, ये गलत कर देते हो आप।
बेटा अभी जितना मर्जी गलत कर लो, कोई दिक्कत नहीं है। एमएमडी
डांट
एग्जाम में गलत मत करना। अभी जितनी गलतियां करोगे उतना अच्छा है। ओके ओके, और बताओ बेटा, और कोई डाउट?